Hello everyone, good evening. Uh, can everyone see the slides? Just write a message yes. Hello, can you see the slides? Anyone can write in the chat
Hello.
box that yes. Hello, hello. Can you people can see the slide? My slide. Just write yes in the chat box. Okay. Thank you, Prach. So okay. So let's welcome you all in the assignment problem solving session 2. So the course name is the Analytical Chemistry, which is taken by Professor Devasis Ray. Uh, and I am Satya Prakash Yadav, a PMRF scholar under supervision of Professor Satish Patil in Solid State and Structure Chemistry Unit, Indian Institute of Science, Bangalore. So today I will just first So first I will give the brief detail about the course. So last time I also I have given that this is the 12-week course. So the I already told you that what are the what we are going to like study in every week. So this Tuesday I'm going to solve some of the assignment problem of week 2, which is role of analytical chemistry and techniques. So if you have gone through the lectures from 6 to 10, so in the first class, basically we have seen what are the sample preparation methods and what are the techniques which we can use for the analysis. And in second lecture, like lecture 7, we have seen the different technique and we have introduced to weighting, which is in presence of nitric acid and sulfuric acid, we will basically decompose the organic molecule. And in lecture 8, we have seen different kind of apparatus like filtration setup and all, and we have seen that weighing how, what is the exact way to weigh. And in lecture 9 we have seen the filtration setup and ignition. In that we have seen about the fusion of.
Hello.
Yes sir. Yes. Anyone has any doubt? Okay. And in lecture 10, basically we have seen uh, we have gone through the different type of crucible, filter paper, and their uses. So let me come to the assignment two, the and the question mark. So what are the steps followed in the filtering and analytical procedure? So can anyone guess what should be the possible answer? And they can write in the chat box which is the correct answer. Answer option A is decantation, washing, and transfer. Option B is washing, decant, and transfer. Or decantation, transfer, and washing. And the fourth one is washing, transfer, and then we have to decant it. So, can anyone tell like which is the answer for the question number one? Write in the chat box. Anyone? What is the answer for the question number one? Any guess? Okay. Okay, 1 minute.
Hello. Is it started?
Yes, yes. Oh, sorry. Okay, sure, sure, sure. Thank you. Okay, let me go through 1 second. I have noted. Actually, the studio is okay. So I will start now. Once again, not an issue for me. So, okay, I am audible now. Hello.
Yes, yes, yes.
Okay, sure. Thank you. Thank you. So, so today I'm going to take one problem solving session on the course, which is analytical chemistry, which is taken by Professor Devashish Ray from IIT Kharagpur. So myself Satya Prakash Yadav, I'm a PMRF scholar from August 2020 batch under supervision of Professor Satish Patel, Department of SSU, Indian Institute of Science. So this I have already gone through in the previous uh, problem solving session that what are all like 12 week course about. So in this week we are going to see the role of analytical chemistry and techniques. Okay. So in week two, basically we have if anyone has gone through from lecture 6 to lecture 10, so in lecture 6 basically we have seen the role of analytical chemistry and their techniques, and in lecture number 7 we have gone through different techniques and we have introduced the weight acing. So in the previous lecture I have told you about the dry acing, and in this lecture professor has told you all about the weight acing, which is decomposition of organic substance under the concentrate nitric acid and sulfuric acid. And then in lecture 8, you have seen about the different kind of apparatus and the what are the exact weighing and the weighing glasses and all. In lecture 9, we have seen the filtration and ignition, we have seen the fusion and all. And in the lecture number 10, we have seen the crucible, this gooch crucible, glass crucible, porcelain crucible, and aluminum oxide crucible. And we have seen the filter papers and theory. So in assignment 2, So I'm going to solve some of 10 problem. So in which the first problem is what are the steps followed in the filtering and analytical procedure. So can anyone tell like what uh, which is the answer for the question number one? Anyone can write in the chat box. Can anyone write in the chat box?
Sir, can you repeat once again?
So first of all, can you see my slide?
Yes, sir.
Yeah, I am in the slide assignment 2, question number 1. What are the steps followed in the filtering and analytical procedure? Can you see this slide?
Sir, actually, the first slide is being displayed on the screen.
Okay, okay. One
Only
minute.
first slide is displayed, sir. Now it's coming second slide.
Okay. Uh, now, now,
Yeah,
Kake.
it's okay now.
Okay, okay, okay. If any problem is there, you can let me know. Right. So, what are the steps followed in the filtering and analytical procedure? Can anyone write tell like what is the uh, answer? Okay, Prachi is saying B, Sweta A. Okay, okay. So some of you like Sweta yes and Saswata Bhattacharya is right. The answer is like A. So first I will tell you like how what is the filtering setup. So this is the filter paper, and this is how we first is a circle. We have to fold it, and then we have to again fold it, and we have to 3/4. We have to open it and keep it in the this funnel. Okay. Oh, PPT got stuck. 1 minute. Okay, and this is the setup where like we have this beaker containing your mixture. This is the funnel, and this is the we have made the filter paper, and we have conical filter. So the first step is like the decant. So first we have to decant it. So suppose we have this beaker. In this we have your precipitate and solution. So basically you have here you have solution. So the first step is carefully decant all the solvent through this funnel and filter paper. So what will happen? So you here you have only the precipitate. Second thing is the washing. So what I mean by washing? So washing means so other than your like analytical precipitate, what are the impurity? That impurity in which solvent it is dissolved. So with that solvent you have to wash. But you have to remember one thing that your analytical precipitate should not soluble in that solvent. So washing is done such that your analytical precipitate is not soluble while your impurity is soluble. So that will be your washing solvent. And then basically you have to transfer from filter paper and do the rest of the analysis. Is this clear? The question number 1. Anyone can write in the chat. Okay. Now, question number 2. So this you have already seen in the lecture 6, most probably in the first lecture. How can you make a physical separation of a solid from a liquid mixture? So in previous question only we have seen that uh, how to make a physical separation of a solid sample from a liquid mixes. Can anyone guess like what is the answer for this question number 2? If anyone has seen the lecture 6, they can easily tell like what is the answer of this question number 2. Okay, I think slide haven't changed. Is it correct? Yeah, 1 minute. I will share the screen instead of slide. Wait a minute. I think it's creating problem. Okay. Now I think it will be correct. Is it fine now? Okay. So the question is how you can make a physical separation of a solid sample from a liquid mixture. So in, the option A is density flotation, distillation, C is filtration, and D is the solubility difference. Okay, so I think most of the uh, people are getting correct. The answer is C. So as we know that like this density flotation and solubility difference, these both are to separate a solid. Like if it is a mixture of two solid, so by density we can separate, that is density flotation, and solubility difference, like you choose a solvent in which one solid is soluble, another is not. This is the separation from based on the solubility difference. And the second thing is the option B is distillation. So what is distillation? So basically like you have suppose mixture of two liquid. So this is to s- to separate two liquids to liquids. So here what happens, you have two liquids which will have the different boiling point. So what we have a column, we have a condenser. Basically here we put the we put the chilling line. So water in, this is a water out. So basically to reduce the temperature here, we put the condenser here. So what happens, so here you liquid, based on the boiling point, we give the temperature here, and the one which has the boiling point at the set temperature, it will vaporize. And here we have the condenser. So here we cool it and it will again become the liquid, and in the reservoir we basically we receive it. So this is the way how we use the distillation system. And the filtration, I have one video. So basically I will just switch on now.
To perform vacuum filtration, we will be using a Buchner funnel and filter
So this
flask.
is the Buchner funnel.
This technique allows us to separate solids from solutions. First, clamp the flask to a ring stand.
This is the very
This will
important
prevent
thing.
the vacuum hose from tipping over the filtration setup.
So
Place the
this is very
neoprene seal
important
in the
thing.
mouth of the flask, then place the funnel loosely in the seal. Place a piece of filter paper in the top of the funnel.
Attach the vacuum hose to the flask.
This is the vacuum filtration.
Turn the
So
vacuum on
basically
using
it
the
will
yellow knob Then
take
wet the
out the
filter
liquid
paper with
very
a
fast.
suitable solvent. This is referred to as seeding the filter paper.
Yeah, first you have
This step
to
is
put a drop
essential
of
as it will position
liquid
the
so
filter
that the
paper
filter
flush to
paper
the funnel,
nicely sits
preventing loss of
on
the
the
solid.
Wagner funnel.
Once the filter is seated, slowly
Then you
pour
have
your
to put the
solution into the funnel.
After the solid has been separated from the solution, disconnect the vacuum hose first and then turn off the vacuum valve. This prevents solution from backwashing into the vacuum system. To recover the solid, invert the Buchner funnel over a watch glass and remove the filter paper from the funnel using a spatula. To perform vacuum filtration,
I think now everyone has got what is the vacuum filtration. So first important thing is that you have to put a holder for your reservoir, and then you have to place that car, a rubber car. Over that you have to put the Buchner funnel, and then you have to put the filter paper. After that you have to put some 2-3 drop and start the vacuum so that filter paper properly sits over the Buchner funnel, and then you have to pour your solution in the Buchner funnel, and then your liquid will come in the reservoir while solid will remain on the Buchner funnel. Then you have to just separate in the watch glass. So everyone is clear about this filtration setup? Okay. Thank you. Now this is the uh, question number 3, which saying that choose the incorrect option for the following processing of the sample. So the option A is solid sample is crushed, pulverized and grinding to make homogeneous. Ideal solvent should be chosen to dissolve the sample including analytes. C option is in case of liquid sample, solvent evaporation does not make any change in the concentration. Option D is the insoluble sample require chemical treatment to convert the analytes into the soluble form. So can anyone guess which is the incorrect option in these 4 options? Okay, Saswata is saying option C. Okay. Anyone else? Okay, so basically, yeah, Saswata and Prasanta both are right. So the first thing is that if anyone has gone through the lecture 6 and 7, so already you have seen that the processing of sample is very important in the analytical chemistry. So the processing of sample processing basically is very important. Very important in analytical chemistry. So basically when we have seen the solid sample, so solid sample first we have to suppose we have one ore, we have some ore, so we have to crush it, then we have to pulverize it and grind it and make a homogeneous throughout for the analysis. And to for a sample, so we have to choose a ideal solvent such that we dissolve our sample and as well as including the analytes, like which is the through which we are going to. In option C, it's saying that in case of a liquid sample, solvent evaporation does not make any change in the concentration. So suppose you have this beaker, or suppose this you have conical flask here. So you have this solution, right? So once you evaporate it, so you have suppose 1 gram in 100, 1 gram of sample in 100 ml, right? So suppose you evaporated 90 ml. So now you have 1 gram in 10 ml. So basically the concentration here, suppose this is C2, this is C1, so here C2 will definitely greater than C1, but it is saying solvent evaporation does not make any change in the concentration because your concentration is A upon W into V. A is the amount, W is the molecular weight, V is the value. Now we have A same, we have W, molecular weight will be same for the sample, but volume we are changing. So C is inversely proportional to value. Now previously it was 100 ml and now it is 10 ml. So you know that C is inversely proportional to 1 by V. So your C2, which is 10 ml, will be greater than C1. And this insoluble sample require a chemical treatment to convert the analyte in the soluble form. We have seen like in the previous once we are once I'm telling you the deer kidney story. There I have shown you that you need to this arsenic oxide. You have to put this acid treatment to get the soluble arsenic 3 plus. So this is the another way to process the sample for the analysis. So now it is correct that option C is uh, uh, incorrect option for this question. So now this is clear. Okay, thanks. Okay, so now next question is, what is the reagent of fusion test of insoluble sample MnO2 pyrolusite? So basically I think this is in the lecture number 7, yeah, most probably more lecture number 7. So this is called alkali fusion. So we have this, sorry, yeah, we have, oh sorry, it is coming. Okay, why it is like that? We have pyrolusite. Okay, so basically which has MnO2. So what we do the alkali fusion here, alkali fusion. So what is that? You have to use the base and fuse it. Okay. So what happens? Your MnO2 in presence of base, suppose we have KOH and air. What it will form? It will form the MnO4 minus like magnet. So basically MnO4 minus and MnO4 2 minus it will form. So first it will form 2 minus K2MnO4 and water, right? And then this K2M, sorry, why it is like that? It is creating. Okay, then what will happen? Your K2MnO4 again have this base, this acid. After that we have to give the acid treatment. It will form KMnO4, MnO2 and this K2SO4 plus water molecule. So if you want to balance, so basically here this 2, so have to give 2, this 2 and 4, and yeah, this is balanced. And then K2MnO4 you have to give the acid treatment, so 8, this is 3, you have to, this will be 2, this will be also 2 to balance it, and this 2 water molecule. So this is what reagent is used for fusion test of insoluble sample MnO2. Basically we have to do the alkali fusion. So in the sample process of this pyrolusite, we have seen the alkali fusion. So the option is A, the KOH or NaOH bead and the mica form. if everyone got this question, this alkali fusion of this amino 2. Okay. So now this is the question, like a sample was weighed 2.156 gram. Which instrument were used for weighing? Can anyone tell, like what is the answer for this question? Can anyone tell the answer of question number 5? Yeah, Saswata Bhattacharya is right. So I think this is in the lecture number 8. So you have already gone through. So about the weighing balance. So I will first briefly discuss about the what are the important things in the analytical balance before you going to weigh. Okay. So first things, once you go, so you have to check whether your label indicator, this one is very important, this is in the middle or not. If label indicator is not in the middle, basically then you will lead to a incorrect reading, right? So to label this, we have two label adjustment here, so by which you have to get this ball in the center. That is the first thing. Second thing is this, the tear thing. So tear means, suppose you want to weigh something, so for that you need some kind of glass or this butter paper, something like that. So once you keep it and tear it, so that if you want to use multiple time, you don't have to write the weight every time. So that is the use of the button tear. Now coming to the question, what is the micro balance? So your micro balance, here you can weigh 160 gram to 200 gram with least count of plus minus zero point 0.1 mg, right? Your micro analytical balance, you can go to 1 to 3 gram with least count of plus minus 0.001 mg, right? And semi micro balance, you can weigh 10 to 30 gram with least count of 0.01 gram. Now here we are weighing 2.156 gram. So you can see that the micro analytical balance V is the correct option for this question number 5. Did everyone got this answer for question number 5? Anyone can write in the chat box that yes. Okay. Okay. So now question number 6. In weight acing process of nickel DMG2 complex, it treated with a mixture of HNO3 and H2SO4 acid. The option A is for the destruction of Ni2SO4 to destroy the organic ligand DMG for the decomposition of H2SO4. D is for both A and B. Can anyone guess the answer? Like I think this is in the lecture number 7, where we have Professor has tell you about the techniques and weight assay. Can anyone guess? Like B, Sweta, yes. Okay, B. Anyone else? Okay, so Sweta is right. The answer is B. So first of all, what is weight assay? Weight assay. So basically here we decompose the organic substance using concentrate HNO3, nitric acid and sulfuric acid, right? So now we have this nickel DMG 2 complex. So what will happen once you treat this with mixture of HNO3 and H2SO4? So the organic ligand, which is DMG, this will decompose into water and N2, right? So basically at the end what you will get, the Ni2 plus ion for the analysis. Like suppose you want to do the volumetric analysis. So you have this nickel 2 plus ion in the ion form, and so subsequent analysis you can perform. So, option B is the correct answer for this. So everyone has got like question number 6.
Sir, वो जो mixture of nitrogen and sulfuric acid to aqua or a simple ratio?
No. Aqua is HNO3 and HCl.
Oh, sir.
Okay. That has some proportion 1:3. Okay. Can I go to the next question? Okay. So which crucible has ability to ignite at temperature 1400 centigrade? Can anyone guess? Like what should be the answer for this question number 7? Okay. Yeah, I think everyone has got right, aluminum oxide crucible. Okay. Can anyone tell like why the answer is D? Why not B and C? What happens if we use this glass crucible at 1400 on centigrade? Anyone can tell? Write in the chat box like what happens if we use the glass crucible at suppose 1400 degree. Anyone can tell like okay, fine. Option D can be tested. That's correct. So thing is that first of all you have to know what material is made of like crucible. So porcelain crucible is made up of this 98% aluminum oxide, so which can sustain up to 1100 degrees. While glass crucible based on the material, whether it's a borosilicate or pyrosilicate like that, it can sustain up to 200 to 500 on centigrade. Goose crucible is basically the borosilicate one, borosilicate, which can hold like 500 on centigrade, more than 500 on centigrade. but aluminum oxide crucible can stand up to 1450 50 degree. So the main thing is here, like, because in analysis, suppose if you are using one crucible which is not stable at that temperature, your sample weight like will change according, right? So the very important thing is that you have to know the exact weight. So for that, the other thing, the contribution from other stuff should be minimal. So your crucible should be stable up to 1400 centigrade, so that whatever that mass you are reporting for that analyte is correct. Okay, so these are the different types of crucible. It can be in the boat shape or circular shape or square shape, like that, any kind of shape, like a different type of crucible I have shown. And that ignition is basically what you have to, what ignition means. Like suppose you have this filter paper, in that you have the your like your compound, suppose nickel DMG. So you have to heat it at 110 degree. So what will happen? Basically, your filter paper will burn, and it will convert into the water and CO2. And water will evaporate at 1 to 110 degrees. So basically, you will get the only nickel DMG. So this is the meaning of the ignition. So you ignite it, and what are the other things? You just like should evaporate, right? So everyone got that why the answer D? Because once you are seeing that what crucible you are using, so you have to see what material it made of. So that material is stable at that much temperature or not? Because oxides are stable at very high temperature. I have told you in the previous problem solving session that weight testing, if you do that mineral of inorganic anion, what will form? It will go through the corresponding oxides, which are very very stable at high temperature, right? So this question number 7 is clear. Can I go ahead for the question number 8? Okay. So this question number 8, from the is like from acidic solution, urea can be effectively be used for removal of. Answer A is NO2 and NO3 minus. Answer B is SO3, so sulfur trioxide and sulfate ion, sulfur dioxide and sulfate ion, carbon dioxide and carbonate ion. Can anyone tell? Okay, Saswata Bhattacharya is saying A. Others can also give their opinion, like what will be the answer. Okay. Okay. I think Saswata, Sweta, and Rahul all are correct. The answer is A. So the thing is that, first of all, why we need these things like urea solution to for remove this NO2 and NO3 minus. So suppose what we are doing, the weight acing, right? Weight acing once we are doing. So suppose we have sample. Once we are putting this HCl or HNO3, like, so be unnecessarily contaminating with the anion like Cl minus, NO3 minus, which we have to like remove, right? Otherwise, these are called interfering anion, right? So this we have to remove. So I think if some of you have already did this BSc laboratory courses, there you have the auxiliary ion is something, interfering anion is there. So once you are going from third A to fourth cation, then you have to remove the interfering anion. So basically, whatever this contamination which interfering anion is there, you have to remove it. So this you can remove with the like sulfuric acid also. You put excess of sulfuric acid and the like some fume will come which is sulfur trioxide. So this is the one way, and one of the simplest way is use urea, HNO2CO, HNO2O. So once you put this this kind of anion NO2 is there, this urea itself reduced to N2 and destroy uh, this nitrate ion and nitrogen trioxide. So this is better method over the H2SO4 because here we have this uh, QPS white fume of SO3 which is harmful, and here we have only nitrogen which is the one kind of inert gas, right? So that's why in acidic solution we are going to use this urea for effective removal of nitrogen dioxide and nitrate ion. It is clear? Question number 8. Anyone can write? Okay, great. Now I will go to the question number 9. 1 minute. It is. So what reagent is used in the qualitative analysis of Fe3 plus iron 3 plus solution from the precipitation for the precipitation of iron hydroxide? So A is hydrogen peroxide Cl minus, B is the ammonium hydroxide NCl minus, C is the H2S ammonium hydroxide and ammonium chloride, and D is H2SO4 and ammonium chloride. Can anyone guess? Okay. Sweta Yes is saying B, Saswata Bhattacharya is saying B, Sunil Pawar is saying B. Okay. Yeah, sure. So you are right. Like the answer is B. So the first thing is that so we have something we have to learn something about solubility product, and one other is the ionic product. Can anyone tell me if ionic product is greater than the solubility product? So our first I will ask like if solubility product is equal to the ionic product. So what is that? It means that it is in equilibrium, or it will be in the salt form, or it will be the solution form. So what I mean by salt form means it will not dissolve completely, it will precipitate out. What I will say in the solution form is it has completely dissolved. So if I am saying solubility product is equal to ionic product, means it is in the equilibrium. Suppose if ionic product is greater than the solubility product, so it will be in the solution or it will be in the salt form. Can anyone tell? So here your ionic product is greater than the solubility product. So Sunil Pawar is saying solution while Prasanta is saying okay, yeah. So I think Prasanta and Saswata is right. If your ionic product is greater than your solubility product, so basically it will be in the precipitate form, right? So I will give one very interesting information about the suppose once we are analyzing the suppose this second group cation where we have copper, cadmium, bismuth 3, arsenic 3, and EsP3, antimony 3. So what we use the dilute HCl and H2S to precipitate this thing as a copper sulfide, cadmium sulfide, and bismuth sulfide, etc. But here we will not precipitate the this your third A cation like nickel sulfide. It will not for cobalt sulfide. It will not for MNS. This thing will not for. Why? Because so first thing, like suppose this is a H2S, it will go to the H plus 2H plus and S2 minus. Now once we add this dilute HCl, what will happen? According to the common ion effect, what will happen? The dissociation of H2S will become small, right? Then the ionic product, which is suppose your copper ion plus S minus, will be the small, because this is sulfide ion is in the small, because dissociation of sulfide is less in presence of the strong acid, which is HCl. So what will happen? Only this second your second group cation, which is copper, cadmium, bismuth, will precipitate, while this nickel, cobalt, manganese will not precipitate. So if you want to precipitate this, we have to use the like better dissociated sulfide, like ammonium sulfide, which is readily dissociated. Then we can find this nickel sulfide and cobalt sulfide also. So this is the like thing where we are using this ionic product and solubility product. So basically here what we take the ammonium hydroxide and ammonium chloride, right? So this dissociation is small, but it is sufficient to form the ferric hydroxide as a precipitate. So your answer is basically ammonium hydroxide NP. Is it clear? Like solubility product and ionic product, how like we are seeing that whether it will form precipitate or not. Anyway, answer A will not happen because H2O2 is the oxidizing agent. It will oxidize H2S, ammonium hydroxide, and ammonium chloride. So H2S, like I told you, like it is for the precipitating the sulfide, that is, and H2SO4 and H2SO4 also an acid. It is used for the basically. Okay, Prach is saying yes, sir. Okay, so everything is clear now for question number 8. Anyone else other than Prachi, like, or anyone has any doubt? Okay, fine. I will go to the question number 9. Oh, okay. Okay, this is question number 9. So I will go to the question number 10. So it's say fill in the blank with a suitable option. In the deer kidney sample, after dry acing, process arsenic present in the sample was primarily converted into arsenic pentoxide, RH3 ASO4, RH3 ASO3, or arsenic AHS3. Can anyone tell the answer? Like in the last class, I have told you already what happens after dry acing. Okay, yeah. Okay, so whoever is not there, I will tell like what is dry acing. So dry acing is basically you are heating at very high temperature, like greater than 500 and centigrade. So what will happen? Your organic substance, if you have organic molecule which is made up of carbon, oxygen, nitrogen, carbon, hydrogen, nitrogen, and oxygen, what will happen? It will form CO2, water, and N2. It will evaporate and their organic molecule will decompose. But what happens to the inorganic anion? So your inorganic anion your inorganic anion or some like inorganic cation, sorry, inorganic cation, what is the most stable form it can go? So we know that there are oxides, sulfates, and nitrates, phosphate. They are very stable at high temperature. High temperature. So this basically your oxide, sulfate, sulfate, phosphate, phosphate, yeah, nitrate. Okay, so the inorganic cation, their oxide, sulfate, phosphate, nitrate. So which is the most stable at the high temperature? That will be the your final product in the dry acing process. So in arsenic case, this arsenic oxide is the most stable. So this arsenic pentoxide will be your the answer. So is Neeraj, is this clear? In dry acing, why your arsenic oxide
Yes.
sure. So some of more thing I will tell like what this is the desiccator. So what is the desiccator? So basically your desiccator is like it will make you the moisture free environment, right? So basically it is used for a sample which are hygroscopic. So we have different kind of desiccator like vacuum desiccator, or we have this what is grease. So this is one kind of desiccator. Here we use basically a substance which can easily absorb the moisture, like anhydrous phosphorus pentoxide, or your this calcium chloride, like this we use here, which will absorb the moisture from the sample. And this top portion here we sealed with the vacuum grease. So we put the vacuum grease all around, and we keep this lid over that vacuum desiccator and close it. So once we close it, we open the sample while little bit. So what will happen? Whatever moisture is there, that will absorb by the your here whatever the moisture absorber is there. So basically here we use this calcium chloride, calcium sulfate, anhydrous magnesium perchlorate, and phosphorus pentoxide. These are the basically chemical drying agent which readily absorb the moisture. So this is the role of the desiccator, and this is the for filtration and ignition of solids. So I already told like there are the crucible, which basically helps to minimize the experimental error, and it will be useful to weigh suitable weighing also. So there are different types of crucible like porcelain, Al2O3, aluminum trioxide, silica, platinum crucible. They have their different usage based on what temperature you are going to use. So this is for the filtration in ignition like that. This is the your acing. So acing basically what you are going to do. Uh, you have your suppose you precipitate out something like nickel DMG. You have filter it over the this gooch crucible which has this sintered pores. So you have or suppose you did an filter paper. So that filter paper you want to acid, so you have to heat it. What will happen? Your filter paper is made of the organic substance that will burn it, and it will evaporate as a moisture and carbon dioxide. And these are the different like measuring balloon. So this is the measuring uh, this is the your burette kind of thing. This is the measuring flask. This is for weighing bottle. Just I am showing you what are the things you have gone through already. So this is the weighing bottle. So and this weighing by difference, this is the like a method where you are going for the suppose you want to make a concentration of x normal, you want to make one y normal. So basically your suppose x is a upon w into v, so that is a1, y is a2 divided by w into v. So x by y is nothing but a1 by a2. That is the called weighing by difference. So these are the thing I just find interesting. So I thought I will just keep it in my slide. So if anyone has any doubt, they can ask me. Otherwise, I will sign out from the meeting. Anyone has any question, they can ask. If anything they have not asked, yeah, if they want okay, this need to be explained, something like that. Okay, thank you, Prasanta. So in next lecture, whatever is there, I will make. I think this time initially I haven't switch on my mic. So next time I will take care. Most probably. Thank you, Rahul. Thank you, Prachi. Thank you all. So you can give any suggestion that need to be improved further. Like I think this is the second class, so I think we will be better over the over once we are going through this, we will definitely improve. Okay, thank you all. I will be signing out now.